everyone, today I will present my mini project for machine mechanism A. My topic is spool and choke bed. We can analyze the motion of a spool when the choke accelerates and verify the results using MATLAB modeling. This problem studies a truck carrying a spool of rolled sheet metal. The truck accelerates forward with acceleration where the spool has mass, radius, and radius of gyration. My objective is to determine the angular acceleration of the spool and the friction force between the spool and the truck bed, and also verify the analytical results using MATLAB simulation. This slide shows the free body diagram, kinetic diagram, and system diagram of the spool. The spool experiences three main forces, including the weight acting downward, the normal reaction from the truck bed, and the friction force acting horizontally. The friction force causes the spool to rotate, and to analyze the motion, we consider both translation of the center of mass and rotation about the center of the spool. To solve the problem, we apply Newton's second law for translation and rotation. For vertical equilibrium, we know that vertical forces depends on reaction force and weight, which will also depends on the mass and specific value g. For horizontal motion, we have friction force depends on the mass and the acceleration at core. For rotation about the center, we have the moment around the core depends on the moment of inertia and the angular acceleration, with the moment of inertia is depends on the mass and radius of gyration. We also consider the rolling condition, which relates linear and angular acceleration. Using this equation, we derive expressions for the system parameters. Through that, we can calculate a moment of inertia, acceleration at core, friction force, reaction force, and angular acceleration, which means we finish the subtask 1. For the subtask 2, we need to create the equation for unknown parameters depending on the known parameters. So for no slipping conditions, we have the equation of angular acceleration and friction force depending on known parameters. For slipping condition, we also have the equation for the acceleration at core and angular acceleration depending on known parameters. To verify the analytical results, we implemented the equation in MATLAB. The workspace calculates the system variables, including friction force, center acceleration, and angular acceleration. The plot compares the friction with the maximum side of friction threshold, allowing us to determine whether slipping occurs. We also create a SimScape 3D model to visualize the motion of the spool under different conditions. For the case where the truck acceleration is 3, the analytical solution here, friction force is 750, center acceleration is 1.5, and angular acceleration is 3. The MATLAB results match this value closely, confirming the correctness of the equations. The graph also shows the maximum acceleration beyond which slipping occurs. So in conclusion, we successfully analyzed the motion of a spool on an accelerating truck using dynamic equations and verify the results using MATLAB. This project demonstrates how theoretical modeling and simulation can work together to analyze your engineering system. And it also highlights the importance of friction conditions in preventing slipping during transport. And that's all. Thank you for listening.